So in this session we will be discussing how to solve the given sample using a decision tree algorithm. So before getting into the concept, the task here is from the given table you have to identify which feature is going to place at the root node and which is going to place as the leaf node for that root node. That should be identified because when you discuss about trees, we have a parent node as well as we have a leaf node, that is child node. So the parent node, we have to place any one of the attributes from the given samples as the root node and then the other as a leaf node. So here which is going to place as a root node, that depends on the gain of the information gain which contributes for the particular attribute when it comes to this sample. So here we are having a data set in which it consists of 6 instances, 6 samples, and each and every sample is contributing some kind of values to the given feature. Here we have A1 as a one feature and A2 as the second feature, and we have an output column. This outcome, based on this outcome, if it is positive, how much information are being gained from A1 and what is the percentage of the information gained from A2. That should be calculated, and which gains more information comparatively, that should be placed as the root node in the decision tree. So first we have to identify what is the information gain of each and every attribute based on the samples which is given, and then we will decide which feature have to be placed at the root node. So to find the information gain, we should know what is the gain of that sample with respect to that particular attribute. So for that we need entropy of S. First we have to identify what is entropy of S. So this entropy of S is nothing but the whole sample's gain. What is the gain of the whole sample based on the outcome. So we see what is the outcome, how many positive outcomes are there and how many negative outcomes are there. Based on that we will find the entropy of the whole set, whole data set. So here according to the given sample, instance 1, it is positively contributing for the outcome, and instance 2, it is positively contributing, and instance 3, it is negatively contributing, and instance 4, it is positively contributing, and when it comes to instance 5, it is negatively contributing, and for instance 6, it is negatively contributing. So based on this, instance 1, 2 and 4, these 3 samples are positively contributing for the outcome. So the values are, it is positively contributing. So 3 samples are positively contributing to this outcome. And how many negative contribution are there? Here it is 3 and sample 5 and 6. So we have 3 negative contributions. So now we have to apply a formula so that we can find the entropy of S. But before calculating it, let me give you a hint of this. If you have both the positive and negative contributions is the same number, equal contribution, then your entropy of S should be 1.0. You can write it without calculating the formula. Or as if you are getting 3 positive and 0 negative, in this case you can directly write it as 0.0, because whenever you are having only one contribution, one instance contribution, or only the one outcome contribution is there, it may be a positive or it may be a negative, in that case without calculating it you can directly write it as 0.0. If it is same number of contribution, you can directly write 1.0 without calculating or applying the formula. And if you have only positive instance, it is 0.0, or if you have only negative instance, if I have 3 negative instance, I have only negative instance contribution here, now obviously the entropy is 0. So this is how the entropy of S should be calculated. If you have different numbers, obviously you have to apply this in the formula and you have to find what is the entropy based on the calculation. As of now, based on the sample, the entropy of S is 1.0. So as we have identified the entropy of the whole sample, now it's time to calculate the information gain for the attribute A1. So we have two different features, A1 and A2. First we will look into A1 and we have to find what is the information gain of A1. For that, you have to find what are the different instances or the values of A1. Mainly the values of A1 or nothing but it is T and F. These are the two values which I have in A1. 3T and 3F. So I have given the values as T and F. So now I have to find what is the contribution of true with respect to the attribute A1 here. So how many positive and how many negative contributions are there for ST? So here I am seeing for A1 and you are seeing for the true values. So you have to find what are the true values that are contributing positively with respect to the outcome from A1. So this is for A1. I am going to calculate the true contribution, true value contribution which are positively over there. So how many true contributions are there? Let us check with the sample 1. In sample 1 I have true value in A1. This is contributing positively. So I have one positive contribution from A1, and for the second sample A1 value is true. Here also it is positively contributing. So we have two positive contributions, and next we have one positive, true value here from A1 which is negatively contributing. All others are false values. So from the three true values in A1, I have two positive contribution and one negative contribution. So let me write this as two positive contribution and one negative contribution with respect to the outcome from A1 attribute. So now let's calculate the entropy of ST. ST is nothing but the sample which contributes from true positively and negatively to the outcome with respect to A1, that is from A1 attribute. So from A1 I have three true values. In this three true values, two are contributing positively to the outcome and one is contributing positively to the, negatively to the outcome. So how this can be applied in the formula is, so generally the formula is 2 is contributing out of 3 positively, right, with log base 2. And here the negative value is minus 1 divided by the whole sample is 3 log 1 by 3 here with base 2. So if I calculate the value of this, then it will give me the value of 0.918. So this is what the entropy of ST, sample true contributions from A1 with respect to the outcome. So similarly I have to find the other value. What is the other value I have in A1? It is false. So from A1 I have to find the sample from false value. How many positive and how many negative values are contributing from false. Here I have 3 false in A1. So the first sample, that is the first record is fourth sample, false contributing positively to the outcome here. So 1 positive, and fifth sample I have false in A1 which is negatively contributing, and in sixth also I have false in A1 which is negatively contributing. So from the false value in A1, 1 is positively contributing and 2 are negatively contributing. So 1 positive and 2 negative contribution are there in SF. So this is how I can calculate the entropy of S of F here. So we will apply the formula over here. Minus, what is the positive contribution? 1 out of 3 sample log 1 by 3, it's base 2. And here similarly I have to apply 2 out of 3 sample is negatively contributing log base 2. So if I calculate this, I'll get the value of 0.9183, which is the entropy of SF. So let me write the result over here so that if I erase, we can refer it. So the entropy of S, it is 1.0 here, and entropy of ST is 0.9183, and here we have entropy of S false, which is 0.9183. So we have the value here, and after that we will be going to find what is the information gain of A1 with respect to the outcome. So let's find what is the gain of S comma A1, because in A1 we have two values T and F. For that we have identified what is the entropy of true value in A1 and what is the entropy of false value in A1. Both are 0.9183. With the help of this value, we will be finding gain of S comma A1. That is how much information gain have been retrieved by the A1 from the given sample S. So here, according to the formula, what is this? Entropy of S. What is the value of entropy of S? The whole set which you have identified at first, it is 1.0 minus, and here you have to find the summation of each and every attribute values gain with respect to that particular A1. So that is, we have 3/6 entropy of S1 and 3/6 entropy of S2. So here we have 3 positive values in A1 and 3 negative values in A1 out of 6 samples. So we have written 3/6, and for this entropy of S1 is nothing but the true value, and entropy of S2 is nothing but the false value. So 3 positive values, in that how many information gain with respect to the positive outcome, and 3 negative value out of 6, in that how much information gain have been done for S2, that is false value, false contribution with respect to the outcome. So this can be calculated as 1.0 minus 3/6 into entropy of ST. ST is nothing but 0.9183 minus 3/6 into this entropy of S false is nothing but it is 0.9183. So if I calculate this value, then we will obviously get 0.0817. So this is nothing but gain of S comma A1. So for A1 attribute, by segregating this true and false values, which is positively contributing and negatively contributing to the outcome, the information gain is 0.0817. So if we write gain of this A1 is nothing but 0.0817. So now we will find similarly what is the information gain that have been retrieved from A2 with respect to the given sample. The same way you have to find for the whole sample. For whole sample, what is the positive values? We have 3 positive and 3 negative. If the positive and negative contributions are same, equal, then you have to give 1.0. If we have only positive or only negative, then obviously you have to give 0.0, or else you have to apply this in this formula and you have to find the entropy of S. So now we have the values ST and SF. We have 2 different values in A2, true and false, that is ST and SF. Now we have to find the gain for ST and SF. If I consider T, you have to find how many positive contributions are there for T samples in A2. So for first in A2, it is positive contribution, and for second true value it is positive contribution, and for fifth true value I have negative here. For sixth sample in true contribution of A2, it is negatively contributing to the outcome. So here I have totally 2 positive. So here I have 1, 2, 3 and 4. I have 4 true values, among which 2 are positively contributing and 2 true values are negatively contributing. So I am writing as 2 positive and 2 negative values with respect to the true values in A2. So now you have to find the entropy of this. So if I find it 2 and 2, they are equally contributing. So without applying the formula, you can write it as 1.0. And let us see for false. I have 2 false values in A2, that is 3 and 4th sample, 3rd sample and 4th sample. F is negatively contributing here in the outcome, and 4th sample F, false value from A2, is positively. So now let's write this as, so for false statement, 1 is positively contributing and the 3rd sample F is negatively contributing. So 1 positive and 1 negative with respect to the false values in A2. So now the value is equally contributing, so the value is 1.0. So now we have to find gain of S comma A2. So we will apply this in this formula for A2. So how I can calculate here the entropy of S. What is the entropy of S value? It is 1.0. Here also I have calculated as 1.0. And minus, so what is the true ST value? It is there. It is 1.0 and SF is 1.0. Among this, how many positively contributing values are there with respect to A2? So I have 1, 2, 3 and 4. So out of 6, 4 samples are true values or having true values, in which so into, you have to multiply the value of ST. And here, so we have 2 false values out of 6 here in A2. So 2 divided by 6 into, what is the value of here? It is SF. That should be substituted over there. So 1.0 minus 4 divided by 6 into, what is ST value? It is 1.0 minus 2 divided by 6 into, what is here? It is also SF value is also 1.0. So now when I calculate this, so the value gain S comma A2 will result in 0.0. The information gain of A2 is 0. So nothing, the gain of S comma A2, it is 0. And already we have found the gain of S comma A1, which is 0.0817. Now we have to compare these two values, which is having highest gain percentage. That attribute or feature should be placed as the root node in your decision tree. So comparing this, it is having 0 value. Obviously A1 wins the race. So I will place A1, which have the value of 0.0817, the highest information gain comparatively. So that is placed as a root node in the decision tree. If I have more than one attribute after this, I have to go with the same kind of procedure and I have to identify which attribute wins the race when compared to, excluding A1, you have to take all other attributes into consideration and you have to apply the same kind of procedures and find which wins the race. That should be placed as the leaf node. So similarly, it goes on until you complete all the attributes which is given from your sample. But now I have only one attribute after this, that is A2. So we need not to calculate again the same procedures. We can directly go with the conclusion. This iteration stops when you come to the conclusion with a single value at the root node. It may be a positive or negative. Each and every leaf node of this tree should result in either positive or negative. A single value should be the leaf node value in that, so that your iteration will get stopped. So now we have A1. So we have to check what are the values that we have in A1. we have true and false, T and F. So if we take T and F as the values for this. So now in this branches we have only A2. So let me freeze with A2 here. So here in true values you have to check what are the different samples that contributing true. Here I have with respect to A1, this is for A1, right? So A1 is having sample 1 true, sample 2 true and sample 3 true. So we have the sample 1, 2, 3 which is contributing true, and regarding false, 4 is false, 5 is false and 6 is also a false value. So let me give 4, 5 and 6. Now we have to check whether we can conclude anything from this with respect to the outcome. We will compare this with the outcome. Whether if all the labels are contributing positive, then it will give the classification as a positive, which is the single leaf node value that concludes with the outcome. So there your iteration stops. So let's check this first value. It is positively contributing the label. It is positive. And second one, it is also positive. If third one is also positive, we can give the positive here and we can conclude the iteration. But here the third sample true value is negative. So we have both positive and negative. We cannot conclude from this. And when we compare this 4, 5, 6. So 4 is false, which is positive, and 5 is false, which is negative, and 6 is false, which is also a negative. So here also I have positive and negative sample from which we cannot conclude either it is contributing positively or negatively, because both comes into the picture when it results in T and F. So in A2 I have true and false values. Let me go with true and false. So in A2, so what are the true samples that are contributing? 1 is contributing true and 2 is having the value true, and 3 and 4 are false, 5 and 6 are true. So let me have 5 and 6. And for false I have 3 and 4, the sample 3 and 4. So if I take this, let me check whether these all are contributing positively with respect to the outcome. So 1 true is positively contributing, and for second true it is positively contributing, and we have to check with fifth sample true, it is negative, and for sixth sample it is negative. So here also I have both positive and negative. I cannot conclude from this. And from 3 and 4, let us check. False is negative, third one is negative, and fourth one is contributing positive. And here also I have negative and positive, so I cannot conclude. So this is happening because here in true values from A1 you are taking 1, 2, 3 sample, but when it comes to A2 you are handling for 1, 2, 5 and 6, which is not fair, because in the first level itself you are taking the samples of 1, 2 and 3. Here you are concluding with 5 and 6 also, hence the results will not be classified. So whenever you are leveling down, you should take into consideration only the labels which are taken for true values from A1. So in this level 2, I have to check with 1, 2 and 3 samples of A2, and you have to categorize into true or false. So now let us check in A2, right? 1, 2, 3. We have to take only the values of 1, 2 and 3 from A2, because the first level iterates with 1, 2 and 3. So here from 1 it is positive, 2 it is positive, and 3 it is contributing negative, but the value of A2 is false. So for A2 true values are 1 and 2 when it comes to 1, 2 and 3 at level 2, and when it comes to false it is contributing the third sample alone. So in this case 1 and 2 are positively contributing, so I can label it as positive, and 3 is negatively contributing, so it is negative. So here I can come to the conclusion that from A2, 1 and 2 samples are positive and third sample is contributing negative. And similarly, this level down, you have to take only considering 4, 5 and 6. So 4 is false, 5 is true and 6 is true. So when it comes to true and false, here it is 5 and 6, and for false it is 4, because we are considering only 4, 5, 6 in level 1. So that should be taken into level 2, and from that we have to segregate true and false with respect to A2 value. So now we have to check whether we can come to a conclusion from this 5 and 6. So 5 and 6 both are true, it is negatively contributing, so I can make this as a decision tape. And for 4 false, it is positive, we have only one value, so we can conclude this with negative samples. So the decision tree which results from this sample is, we have A1 as a root node which gains the maximum information when it competes with A2 0.0817 value. So this is the root node and we have two values, true and false. In this I have two samples of 1, 2, 3 and false sample of 4, 5, 6. And the next only I have one label that is A2 that should be taken into consideration because no other value, so we can directly take it. If you have more than one values, then you have to again iterate from the scratch and you have to find which information, which attribute is having more information gain, and that should be placed in this label. And here I have true and false. You have to take only this into consideration, 1 and 2, and here it is 3, and true and false here. So 6 contributes false and 5 and 6 contributes true and 4 contributes to false value. And from this we have concluded this is a positive decision and this is a negative decision. And here it is a negative decision and here it is positive decision. So this is how you can conclude the decision tree when you process any samples using the formula. First you have to identify the entropy and then the information gained for each and every attribute. Which attribute is gaining the maximum value, that should be placed as the root node, and the next level it should be placed as the leaf node. This should be iterated until you can find with the single value as a decision. The output should come as a single value in the leaf node. Thereby you can stop your iteration. Thank you.